Welcome everyone to the session where we will be talking about using runtime and working with ArcGIS Online and enterprise portals. My name is Devesh Goyal and I have with me my colleague Nathan Castle. And we both work on the runtime development team at Esri. But just to get a sense of who's in the room here, how many of you are new to runtime, say never used it before, used it for 6 months or less? Okay, about half of you. And how many of you in the crowd are .NET developers? All right. Do we have any Java developers? Android? iOS? Cute? All right. How many of you signed up for Dodgeball later today? Some of you. I'm taking notes, so if you go easy on the questions, we'll spare you. So this is the agenda for today's talk. What we'll do is, since many of you are new to runtime, we'll just start off with a brief overview of runtime and portals, and then we'll get right into using portals. We'll talk about how your apps can access a portal, how do you consume content in a portal, and sometimes even add content back into the portal through your apps. So ArcGIS Runtime is a tool for developers that allows you to build native apps. And the runtime brings a vast number of geospatial capabilities. So in your apps, you can do something simple like just display a map, or you can do something more advanced like edit the data in a map, search for features, do routing, or perform analysis. It's really up to you what you want to do with runtime. But we support a vast array of geospatial capabilities. Using the runtime, you can build native apps that give you the best speed and performance. And it also allows you to integrate with existing developer frameworks, especially that modern platforms now provide. So things like .NET that Microsoft provides, or iOS, which Apple gives, or Java, or Android. So you can take advantage of your skills with those frameworks and use runtime in those environments. And then you can use ArcGIS Online or ArcGIS Enterprise to bring GIS content and capabilities to your app. You can do this on many different platforms and many different devices. And you can even work offline and retain many of those capabilities because runtime is engineered to work with a lot of data without any network connectivity. So the way we build runtime is that we develop a common core using C and C++. And the reason we do that is because it gives us the best performance possible because it runs really close to the metal. But also it allows us to be portable so we can run it on a variety of different platforms. Now, if we expose these core components to you in C++, it'll be pretty unwieldy for you to build your apps because it isn't the most productive language to work with, even though it's great when it does work. So what we do is we wrap these core components in a thin veneer of APIs that are built using .NET or Java or iOS so that you can use those programming languages to build your apps. But because we have a common core underneath all of those APIs, it means we have the same capabilities and functionality across all the different SDKs we support. And we also use the same conceptual model and patterns so that when many of you go from developing, let's say, a .NET app to an Android app, you don't have to relearn the runtime, and the same patterns and practices just need to be applied in that new environment. So that's a little bit about runtime, but switching gears and talking about portals. Portals are great because they help organize your organization's GIS assets. Think of a portal as a content management system or a central repository for all kinds of GIS assets like maps, layers, packages. Portals really allow your users to discover the content that your organization provides and then engage with your organization as they use the content. But it's not just that, because the portal also empowers your users to create new content, either through simple web apps or through desktop and mobile apps that you might build with runtime, or using the advanced professional apps that we provide. And the ArcGIS platform's really gone a huge transformation over the years. It started way back with just us providing desktop applications that allowed a GIS professional to work with files on their machine, and they created maps that way. And then they hired more GIS people in an organization, and they all needed to collaborate together. And that's when we moved to the server GIS model, where all of this data could be shared on a server, and different people could connect to that server from their workstations and use desktop apps to sort of collaborate. But now we've moved into the Web GIS model, where you need to take the same data and share it with people outside of your organization at massive scale, and allow people to work with that data using any kind of app, be it a web app or mobile app. So the Web GIS model is available in two flavors, really. It's available in the cloud, in something we call ArcGIS Online, and that is a way that Esri provides the portal. And there's a public component of that that's open to everybody, but organizations can sign in and they get a sandbox in that portal that's just open to their users and cannot be shared outside if they don't want. But you can also take that WebGIS model and install it completely behind your firewall to keep things secure and on premises, and that's what we call ArcGIS Enterprise. But it's the same software components working together and the same architecture. So whether you use ArcGIS Online, which is software as a service, or you use ArcGIS Enterprise, which is just software that you install, it depends on a variety of reasons. Some typical reasons for using enterprises: you're not interested in moving to the cloud, or you have some governance controls or some SLAs that require you to make sure that you provide that information. And maybe your users don't even have an internet connection where they can't access ArcGIS Online, and they need to access everything within their network. Well, then enterprise is probably a better fit for you, but then you're responsible for maintaining that deployment, upgrading it, and making sure it's working great. But if you don't have any of those restrictions, then ArcGIS Online is great because there are fewer administrative tasks. Esri takes care of making sure they're upgraded and scaling it as your number of users increase. So it's much easier for you to sort of opt into. Like I said before, a portal's a central repository for all kinds of information, be it maps or layers or real-time data, raster imagery, or enterprise data. And the way the portal does that is through a very logical Geo Information Model. At the top of it is the organization, which represents the portal. And then that organization has users. Those users create items which represent those GIS assets. And those items can be kept private for a user, or they can be shared to groups where other users can collaborate with those items. And there are different types of items, whether they're a map or a scene or a layer or an application. So that's the basic model. And that model is exposed through a REST API for developers. So developers such as you can use the Runtime SDK to access the portal information, or you can use JavaScript APIs if we provide Python, or you could just use any other language that allows you to call into REST to tap into that information inside a portal. And that is the same model that we use at Esri. So we dog food all of this by building our apps that access the portal using those REST APIs and the SDKs and higher level APIs that we build. So it's tried and tested, and it'll work in your apps should you decide to use it. Some of the practical benefits of using a portal are that your users can bring their content to your app, which is really powerful. You can build a generic app that works with any kind of content. Even if your users are not bringing content, sometimes when you're providing content, you can easily curate content that your app provides. Instead of hard coding it into your app, you can just create some groups on a portal, wire up your app to use that group, and as time goes on, you can keep changing the information in that group to allow your app access to more data. It also allows you to take advantage of a powerful pattern of configuration. You don't have to code everything. For instance, if you're using maps or scenes, You don't have to write code to add layers, set symbology, create bookmarks. Users or you can do that very easily in the portal using web apps and set up all of this ahead of time. And then your programming pattern becomes very easy. It's just opening that map and honoring those settings that the user chose. And then finally, if your apps connect to the portal, you also have the option of using the user's account on that portal to license runtime in your apps. So the runtime has a tiered licensing model where we provide more capabilities with each higher license level. The light and basic license levels can be unlocked with a portal user. So if you have a user who's got just viewer privileges or level 1, then they can just access maps and scenes and be able to even work with them offline. They can perform analysis like routing and geocoding and use other analysis services available on your portal. But if the user's a level 2 user or sort of an editor or field worker or a creator user type, then they get more capabilities where they can even edit the data inside the map and then be able to access and create new content in a portal. So once you've decided to build your apps against a portal, what do you need to do? Step number 1 is you need to connect to a portal to access its content. And the way you would do that is the SDKs, the runtime SDKs, provide a very high-level portal object. You just give it a URL to your portal. But at this point, the object doesn't go ahead and make a connection to the portal because most of our objects in the SDK, which connect to remote resources, use a loadable pattern, which is you need to tell them to connect so that it remains very efficient and doesn't make connections when it doesn't need to. So you call load on it, then that establishes a connection with the portal. And you can choose to provide credentials if you want it to connect as a user of the portal, or you can let the authentication manager inside the SDKs challenge you if a user is required to connect to the portal. Some portals allow anonymous access, so in that case, a user is not even required. If a user is required to log into the portal, there are a number of options that the portal administrator can choose to enable security. We support, for instance, container-based security mechanisms on the portal side and also in runtime, where you can use things like integrated Windows authentication or digital certificates to sign the user in. Or OAuth, which is a very common way these days to sign people into web systems because it allows integration of third-party identity providers and make sure that that identity is protected from the app developer and it's only exchanged between the backend portal and the user. And when a user signs in, you get information about who that user is, like their names, their email address, what role they have on the portal, what privileges they have, and what content they can access on the portal. So with that, let's go ahead and switch over to a demo where I can show you how you can connect to a portal. In this case, I'm going to be using Swift and the iOS SDK to do it, but like I said, because runtime is built using a common conceptual model, you can use .NET or any other SDK that we support. So I have a very simple app here. This is a storyboard. Basically, I have a sign-in page at the beginning. It's got one button called Sign In, and it's got a segue that connects it to the next view controller, which shows some information about the user who just signed in. This do sign in method is called when the user hits the sign in button. In that, I go ahead and create a portal object and I pass in the URL to the portal I want to use. In this case, because the portal allows anonymous access, I said login required is false. So if I go ahead and load the portal, and this is an async method, so I have a callback that happens after the portal's loaded, I can just go ahead and proceed to the next view controller. Let me go ahead and run this. Now, I'm not really checking the error here because I've done this before and I know it works, but typical pattern is after you call an async method, you check if there was an error, and if so, you handle it. But in this case, it'll work. So I'm going to go ahead and click the sign in button. It'll go ahead and load the portal and take me to the next view controller. And there you can see that all of the information's, sorry, the color's a little hard to see, is not available because I really don't have a user whose information I can show you. And if you can read this, it says the runtime's licensed at the developer level. So by default, when you start building an app with runtime, you get access to all the capabilities so that you can develop and test with it at the developer license level. But when you go to deploy your app, that's when you need it to be at one of the deployment license level. So in this case, I signed into the portal anonymously. I don't have a user who's associated with the connection. But if I come back to my app and I go ahead and flip this bit to true, where I tell it to force me to log in so that a user identity is established, and hit run again, you'll see that this time when I go to sign in, I get a prompt to enter my credentials. And this is the authentication manager in the SDKs that is kicking in, because it realizes that in order to establish a connection, a user identity must be established. And I haven't written any code in my app to do this, but the SDKs provide some default way of collecting user information. So I can go ahead and enter this information here, but I really want my app to use OAuth. So what I can do is very easily, before I call sign in, I can give the authentication manager some OAuth details for my app. So in this case, I create an OAuth configuration. I pass in the client ID of my app and a URL to redirect to, and I give it to the authentication manager by adding it to its OAuth configuration. This client ID I was able to generate very easily on the portal by creating an item, which is a mobile application, and then going to the settings and scrolling down to the bottom where there's registration section, and you can register an OAuth details for your app, and it gave me this app ID that I'm using. And this is a special URL that my app understands that it uses to make sure that the authentication works correctly. So now that I've given it my OAuth details, I'm going to go ahead and run the app. And now what you will see is that the OAuth manager, instead of giving me just the default username password window, it brings up the OAuth web page for the portal where the user will sign in. So that's the web page. It's accessing my portal. That's the name of my app, portal login, and it's telling it it's developed by this organization. So your users know that they're giving their credentials to a trusted authority and not some rogue app developer like me. Or you. So I go ahead and sign in, and I'm taken to the next page, and voila, all the details of the user who signed in have been filled out. Because the user identity has been established. And if you squint and see real hard, you can see that the runtime license level now is at basic because it's been authorized with the user's identity. So if I go into the profile view controller, which displays all the details, it's really simple. What it does is it basically looks at the portal and sees if it has a user associated with it, which will be populated when you connect using some user details, and pulls out the information like full name, username, email, etc. The portal also has something called a portal info object, which has some licensing information. And I get that license info and I set it on the ArcGIS Runtime environment to license runtime. using my user's credentials. So that was my demo for connecting to a portal, and now I'm going to hand it to Nathan, who's going to talk about accessing content from a portal.
All right. So we saw how to log into the portal, how to get details about the user. Now we're going to talk about how to access content that's in the portal. So first I want to talk about the types of content that can be stored in portal. Then I'm going to demo some portal connected apps, including some ArcGIS apps, as well as a code demo. Then I want to talk about the different sections that users experience in portal, including their content, their organization's content, and groups. Finally, I want to talk about search and pagination of searches, and some notes about how to access additional resources that portals can offer to make your app stand out. So portal items consist of content and metadata about that content. And there's a variety of content that can be stored in them, including links to resources both inside and outside of your organization. You can store binary files. For example, the ArcGIS Runtime samples organization likes to publish our sample viewer apps as portal items as a preferred way of sharing. And you can, of course, also share GIS content in your portal, things like services, layers, maps and scenes, shape files, etc. Now, a portal item also has a type property, which tells you what the content it contains is. Apps should use that to properly handle opening those portal items. So for example, if you have a map, it's really easy to create that map from the portal item and then show it. Same thing with scenes. Now there may be items that your app can't support. For example, ArcGIS Earth only supports content that can be shown in scenes because it's a scene-based app. So when they make their queries, they're not going to get things that they can't support, because they can query by type. And then there's other metadata, things like description, when it was created, when it was updated, how many times it's been viewed or downloaded, terms of use, as well as a thumbnail that you can give your users to make it really easy to identify the content they're looking for. Now, I want to be clear that there are two broad categories of things you'll see in portal. So some things are ArcGIS types, so things like map services, feature services, web maps, layers. And you'll find a lot of places in our API where we refer to portal items, and we can make it really easy to open, for example, feature layers from a portal item directly. Now, there are other types of content that you may still want to support, things like Word documents, PDFs, zip files. We can't necessarily do as much with those, but we can always give you the option to download it or link to the document. And here's a good example of what the portal item constructors will typically look like. The only caveat here is you want to make sure that if you give a portal item to a map constructor, that the portal item actually represents a map, because if it doesn't, you're going to get an exception. Now I want to show you a demo quickly. I have a touch bar Mac and I can't find the escape key. This is, okay. Now we're going to show a demo. So I want to go through ArcGIS Earth, because this is an example of an Esri app that uses our ArcGIS Runtime. It also uses portal functionality to connect to Enterprise and Portal. So notice how the default base map in ArcGIS Earth is an imagery base map. Let's pay attention to that as I log into my organization's portal. Now I want to point out this is the OAuth functionality that Devesh showed off earlier. Now, one of the really cool things that I like about Portal is it's not just content, it's also settings and various resources that your app can access. Now, one of those things that you can configure as part of Portal is a default set of base maps. So here we see for this organization, the topographic base map is the first one. So when we loaded and we signed into Portal, the app new to show that base map, as well as to show these as the options for changing. Now I want to take a look at the content section because this is where a lot of the value comes for users. Now notice that because I'm logged into Portal, there are a few options. There's my content, my groups, and my organization, as well as all. All gives you access to all of the content that's available in Portal. So that's things from the Living Atlas, that's Esri authoritative content, and that's also other content shared by users of ArcGIS. There's my content, which is content associated for this particular user that's logged in. There's groups, which includes all of the maps and resources that are shared with the groups that I'm a member of. And then finally, there's the organization's content. And I can click on any of these maps and load them on the scene. And this is all using the same runtime code that Devesh showed off earlier and that I'll go into more detail with later. Now I want to show off another app. In this case, it's the Explorer for ArcGIS. This is a beta app I downloaded from the Microsoft Store. I'm going to log in. All right, now in this case, Explorer is a good example of an app that only supports a certain subset of content, in this case maps. And so they know not to request content that they're not compatible with. So you're not going to see scenes, you're going to see just maps. I'm actually going to log into a different portal, and I want to show you an example of them supporting downloadable content. In that case, log in. So here we have several mobile map packages, and these can be downloaded and then opened in the app. And here's one that was available offline. And for my last demonstration, I want to show this is a demo app, and it's going to be shared publicly in the ArcGIS Runtime demos for .NET repo. And you will be able to see the source code for that as part of that Git repo. So one detail I want to add to the discussion about, we've talked about portal items. Runtime also has the concept of local items, which don't come up too often, but it is a useful concept, especially because it can help simplify some of the code. So you see there are tabs, there's local content in my folders. One of the implementation choices this app made is when you take a map offline, it's stored as a local item. And it has all the capabilities that other local or other portal items will have. So you can see the metadata. You can open the original portal item in ArcGIS Online. You can watch as the app crashes because there is apparently a bug. That I thought I had fixed. So here we see, just like the other apps, I have access to my content. I also have access to content in my folders. I mentioned earlier that the ArcGIS Runtime team shares our sample viewer apps in Portal, and you can see we have some of those here. Now, if I'm only interested in a specific type of content, this app supports web maps and web scenes, for example. I can click on that, and I can open those. Now, this map view is using we have a base map chooser, and this is based on the same sort of code that I showed off in the other apps. And it really is only one line of code to get this base map once you've loaded your portal, which is really awesome. We also have access to groups. And finally, I want to talk about search. One of the exciting things about Portal is you have access to not just your organization's resources, but also the full resources of, if you're using ArcGIS Online, many other portals. So right now I'm going to search fire. And so I have this mobile map package that has, I think it's tagged fire because it has a fire map in it. But I can go here and include public results, and now I can see all sorts of things from different maps or different organizations that have shared things. So I can click on this, and I see this map of the rim fire at Yosemite from a few years ago. All right, so I'm going to go back to the presentation now and talk about some of the code that enabled this app. So Portal and a runtime, we make it really easy to find the content that's relevant to your user. As you can see here, it's only really just a handful of API calls, and you can get just about everything you need. And like Devesh mentioned, these are all asynchronous, and the pattern is a little different depending on the platform you're targeting, because we follow the platform's pattern. So this is C#, so we have the await keyword rather than a callback. You can also query for items in a particular folder, which is used to get that list of folders and show the content in each one. Content constructors. They're available for a lot of ArcGIS types, including maps. In the recent release, we added support for scenes, so you can create a web scene, or you can show a scene from a web scene document very easily. As mentioned before, and you can see here, you always want to guard and make sure that the type that you're showing of the portal item matches the type that the constructor expects, because if you pass a web scene to a web map, we don't know what to do with it, and we will throw an exception. We have similar constructors for a lot of things. We have them for maps, scenes, feature services, ArcGIS map services, and a few others. Your organization may have content. One of the reasons why you want to support, for example, loading the organization's base maps for the base map picker is because your organization or the user's organization may have, for example, subscribed to premium base map content or premium imagery. They may have base maps that are particularly relevant to their line of work. And we make it really easy. It's that one call to get base maps async, and then you have the list of base maps which you can immediately turn around and use in your apps. Oh, and I should mention featured items. When you log into a portal for the first time or you go to the home page, it can be configured to show a set of initial default items. And we support retrieving those and showing them as well, although we didn't see that in the demos that I showed. Now, groups. Groups are one of the primary ways that you share content within an organization, especially if you only want to target people that are relevant to, or give people the content that's relevant to them. You can also use groups, as Devesh mentioned, to configure out resources that your application will load or show by default. And we make it really easy. You can do that by either getting a list of the users' groups, or if you know a group ID, you can hard code that and query items in a specific group. You can also search for groups and search within groups. And up here you see an example of a query for finding all of the groups matching fire with the owner, Nathan Castle, that's my name. You can also search for all of the groups in a portal and show those. You saw with the Explorer app a good example of an app that can only support a handful of portal item types. And so what they're doing under this, or behind the scenes, under the hood, is only searching the portal for the content types that they can support. They don't even bother pulling down content that they can't do anything with. And you can do this. We have a few different types of helper methods for this. You can do create for items of type and group, create for items of type, and there are a few different variations on that. to simplify the coding pattern. Now I want to talk about pagination, primarily because with Portal and with ArcGIS Online, you'll often run into situations where you might have 50,000 items. And if you try to run a query for 50,000 items and pull that down all at once, it's not going to work very well. It'll be slow. You just don't want to do it. So all of these query methods come with, or excuse me, all of these query parameters objects have properties for setting these, the limit and the start index. You use the limit to control how many items you have per page, and then use the start index to control which page you're on. And I skipped that part of the demo earlier, so I'm going to go back to the search experience. And show how this works. So repeating that search for fire. I have one thing here, but if I include all results, there are 47,000. But I didn't pull down all 47,000. I just pulled the first 25. And I can page through this really quickly with essentially no delay and with very little resource usage because I'm only pulling down the items that I want for any particular query.
No wonder apps crash for you. That's the way you treat me.
Now I want to go over some more convenience methods we have. I've been focusing on items. We also have queries for groups. We have queries for users. And we have a lot of variations on these, as well as I mentioned earlier, the get featured items and the get base maps, which are going to be really useful for integrating your app with the GIS and making it feel like a first-class part of that user's enterprise GIS. Now, I should mention that all of the queries that Runtime makes are against ArcGIS's REST API. This is documented well on developers.arcgis.com. And you can customize all of these queries. So you can get the query that Runtime generated. You can change it before sending it out. Or if there's a query that is too complicated for the Runtime object model to handle, you can write that query yourself and send it along using the Runtime infrastructure without having to deal with authenticating yourself, doing the HTTP request yourself, or essentially doing any of the other nonsense that we do for you. Now, the last thing I want to talk about is hosted services that you can access through Portal. Many organizations will have their own locally hosted content, which is particularly useful, for example, in offline scenarios or in scenarios where you have access to your enterprise, but you don't have access to the network. You don't want to be hitting Esri's world elevation service if you don't have access to the internet. Your app can check the portal for alternative resources for the elevation services, which you'd want to use in scenes, for routing, for traffic, geocoding, geometry, and analysis. When your users log into their app with Portal, they expect to have access to their Portal resources, and this is another part of integrating fully with the GIS. All right, I'll hand it back to Devesh to talk about adding content to a portal.
Cool. Thanks, Nathan. All right, so that was all about connecting to a portal and consuming the content already in there. But there might be times when your users want to create new content right from within your apps. Some of them might want to create new maps and add layers to them. But that may not always be the case. It could also be just an app that's connecting to your business systems, pulling down some data, converting them to CSV files or packages, and then uploading them to a portal. So all of those involve adding something to the portal, whether it's user generated or that your app's generated by connecting to other systems. And the runtime supports that. We have two basic workflows that you can use to add content. The first one is what we call a coarse-grained workflow. And this is where you're working with high-level types in the runtime, where runtime understands the content and can actually create that content in the right format on the portal very easily. And then the next is the fine-grained workflow, where we provide a very generic API for any type of content you want to add, but you as the application developer need to know what the content is and how to provide that type, etc. So the coarse-grained workflow, for example, can be used with the map API type that we provide, which represents web maps. So you can really very easily create web maps in portals. We have some convenience functions on the map API, which is save as to create a new map or save to modify an existing map. And those functions know what layers are in the map, what renders have been set on the layer, what scale range, etc. So they can save the web map in the right format for you. All you need to do is work with the map and use its API to create it or modify it. But then if you want to do or if you want to add other types of items, we provide this generic API on the portal item or the portal user, where you can add any generic item to the portal. You're responsible for setting what type it is and providing data in the right format, etc. But then we have conveniences to transport that to the portal and persist them. Once you've added content to the portal, or you're consuming existing content even, you can change the sharing settings of that item. By default, all items that are created are private. That means they can only be accessed by the user who created them. But the portal allows an item to be shared with a specific set of groups or shared with the whole organization. So any member of the organization can access it, or with the general public. And the way you change these sharing settings is, again, on the portal item, there are some really high-level conveniences methods to allow you to toggle this and also get the access level of that content. So with that, I'm going to go ahead and jump into a demo that shows us how we can create and add new content to the portal. Back to Swift, sorry for the .NET developers, you have to see more callbacks. But what I'm using here, instead of building an app, I thought I'll just use a playground, which is it's an environment that Apple provides for quick, rapid prototyping with Swift. So as you write some code, you can hit play and you can see the results in the sidebar. So what I've done is I've gone ahead and created a portal object pointed to my organization. And instead of using the authentication manager to sign in, so I'm afraid you guys are writing down my passwords, I'll go ahead and set the credentials already on the portal. And then if I hit play, you'll see it's created this portal object for me, right? I can also go ahead and in this environment, display a map. So I created a map. I set a base map on it, which is the dark gray canvas layer. I'm adding an operational layer to my map, which is a tile layer showing the uninsured population in the US. And I can set the map on a map view and display it right here within this playground. So that's the map. I can go ahead and interact with this and zoom in, and then hopefully the operational layer comes into play. The darker areas show states with higher percentage of uninsured population. And then if I want to save this map, I basically give it an initial viewpoint, which is the current viewpoint I'm looking at in the map view. Zoom in a little bit more. And I can call the save method on a map, giving it a name, telling it which portal to save it in, give it some tags and a description, and hit play. Hopefully when this completes and I jump over to the browser, go to my portal and looking at my content, if I go ahead and refresh this, voila, I have a map. I can go ahead and click on that, open it up, and it will have the same configuration that I set up in code in terms of the layer and the viewpoint. If I go back to my content page, you'll see right now it's shared with nobody. By default, it's private. I can go ahead and write some code to easily share it. So I can go ahead and take the portal item from the map and share it with the organization. If I go ahead and play that and go back to my browser and update it, you can see now it's shared with the organization, or I can share it with everyone or groups if I want to. So that's about saving maps, but we can save other types of content using the generic or the fine-grained API. So in this case, I have a KML file in my playground, which is called US States Capital. I'll create a portal item object, which I want to create on that portal. I'll say the type of that item is KML. I'll give it a title, give it a description, some tags. I'm getting the path of that KML file from my playground, and then I'm using the file manager APIs in Swift to get the data, the binary data of that file. I'm creating this item content parameters with the data of that file and give it a name. And then on the user object of the portal, I can call add and give it that portal item with the parameters. So this should go ahead and take that KML file and upload it to ArcGIS Online and set it as the right type. If I go ahead and come back here, you can see I have a state capitals KML file. I can click on that and say open in map viewer and see that data on my map, or those push pins. So it's really simple APIs that you can use to add new content to the portal. So just a brief recap over the session, we gave you a little bit of an overview of the runtime and what a portal is, and then how your apps can connect to the portal, the different security types that we support, and we showed you examples of using OAuth. Nathan talked about consuming content in a portal, querying for groups, looking at items inside groups, pagination, and then we talked about adding content to a portal. The portal REST API is huge. It's got a number of endpoints for administration, for publishing. We haven't exposed all of that API through runtime. We focused on just a sweet spot where we think users will be using it to consume content and create new content. However, if your apps need to do any of those functions, you can call those REST APIs directly. And the runtime SDKs provide some lower level request operation type classes, which allow you to pass JSON easily back and forth between the portal. And we take care of the authentication for you, so you don't have to muddle with that just by using pure REST API based applications. That's all we had for you in this session. We'd love for you to take our survey and tell us how we did. 5 stars if you can, meet me outside. And then we'll take that into account as we do this next year and tweak it so that better fits your need. We've got a bunch of more runtime sessions coming ahead today and tomorrow. And if you have a time machine, you can go back and see all the ones that were before this, or you can go to YouTube, whichever is easier. It's up to you. But that's it. Thanks for coming, and I'll open the floor to any questions.